Hey guys, welcome back to Michelle's STEM Journey. I'm Michelle and I'm here today with the 6th video for my AIME series. Today's video comes from the year 2020 and it's problem 6. I hope you guys enjoyed this video and let's get started. The problem states a flat board has a circular hole with radius 1 and a circular hole with radius 2 such that the distance between the centers of the two holes is 7. Two spheres of equal radii sit in the two holes, such that the spheres are tangent to each other. The square of the radius of the spheres is m over n, where m and n are relatively prime positive integers. Find m plus n. So the best way to start off this problem is to just draw the picture out. So we first have two circular holes, and then we have two spheres that sit into these two holes. So if these two are the two spheres that sit inside the hole, we know that these two, the radius is the same. So if that's the center, the radius would be the same. However, as they sit into the two holes are different sizes. One has a radius of 1 and then one has a radius 2. So if this sits in hole number 1 and this sits in hole number 2, then it should be clear that one is taller, or I guess it sits higher than the other. And so that means that the centers would not be the same anymore, because we see that if they sit into the two holes, then it doesn't just simply sit on it, but rather it'll sink down into the hole a little bit. So that means that if we have the circle, we have the two circles, then the radius or the center of the circle for the one that sits inside the hole with radius 1 would be higher than the other. And we know that the two circular holes are on a flat board. So if the board is like this, if the line represents the board, then that means that, as we can see, the circle that sits in the hole with radius of 1 doesn't sink as much as it does with the one that sits in a circular hole radius 2, because obviously there's more room in radius 2. So what we need to identify here is that I'm going to let this point and this point be the center of the circular holes. So it tells us that between the centers of the hole is 7, and so this would be a radius of 1, this would be a radius of 2. And then in between, this is not drawn to scale, but in between would be 4, since the distance from the two holes in all is 7. I'm going to connect the centers of these spheres. I'm going to let what we're trying to find, so the radius, I'm going to let the radius be r, so that means that they're equal. Both of these would be r. And then I'm going to connect these two. So what we want to do is to set up an equation that has r in it, and we're going to solve for r. So we see that we have two triangles here, and I'm going to draw the heights of each. And then we can represent the height, because keep in mind that this would also be r and this is also r, because they're all radius. So that means that the height would be the square root of x squared minus 1. And that's just because 1 squared plus the height squared is equal to r squared. Rearranging that, we get the height is equal to the square root of x squared minus 1. And so the height for this one would be the square root of x squared minus 4. And this line goes through the point of tangency. This is a point of tangency. And so I'm going to draw the perpendicular bisector of the chord. And so now I'm going to draw a height that goes from the center of the square of the circle that sits in hole with a radius of 2, and I'm going to draw it to where it forms a right angle with the height of the circle that sits in hole number 1. And so now we have a right triangle. Okay, we have a right triangle, and we can use r to express all 3 of its sides, so we can set up a Pythagorean theorem equation. So we know that we can start off with the little side. Well, that little side is equal to the whole side, which is x squared minus 1, minus this part. And keep in mind that because I drew a perpendicular line, that means that this part is equal to the height of this circle, of this height of the triangle in circle 2. So we can just subtract that to get the length of the little leg. And then we can square this plus the other leg, which is just 7 squared. This is equal to 2r squared. And then we can just solve. I'm going to expand the first part of the equation to get and then I'm going to move the 2r squared over to get minus 4r squared. And then I'm going to move the 49 over to get negative 49. And then we're going to combine like terms to get negative 2r squared. Okay, so basically in this equation right here, all the x's are technically just r. Because x is more commonly used, so I just use x. But just remember that x and r are the same thing. Okay, so now we've solved for r squared, which is perfect because with the equation, it led us to solve r squared, so we don't even have to square r. But we get a fraction, which is exactly what we need, and then we reduced it. So now it would be 160 plus 13 to get 173. So our answer is 173.